orthographic and oblique. So in the orthographic we have elevation and axonometric, and oblique is Cavalier and the cabinet, and the axonometric is further of isometric view. Here you see, this is the eye, this is the what the converges at a eye point. In the parallel, no conversion is here. The scene is going parallel, which they are not meeting at any point. So this is the basic difference between the perspective and the parallel projections. Here you see, in the orthographic, rays are perpendicular to the view plane, and in the oblique, rays at angle to the view plane. So in the perspective, rays converges at a eye position, but in the parallel, rays are parallel, they are not meeting at any point. But in the orthographic, rays are perpendicular to the view plane, but in the oblique, rays at angle to the view plane. Here you see the orthographic and this is oblique type. So what this orthographic says, the rays are perpendicular to the view plane. So this is how you can see, this is perpendicular, and in the oblique these are at some angle. So this makes an angle in the oblique type parallel projections. Here you see, the man-made objects often have cube-like shape. Not all, but we can see all the objects can be seen as a cube-like shapes. So these objects have three principal axes. Here you see, this building have three principal axes. The one is x-axis, y-axis and z-axis. Here x-axis, y-axis and z-axis. So this all is defined in these three axes, is known as three principal axes. Here you see the one point perspective, means where you can see only the one way. So you are seeing the one way. It depends on how many principal axes interact with view plane, and in the parallel lines not parallel to the view plane have the same vanishing point. So here is the two perspective vanishing point where the one principal axis intersects view plane. So we said it is 2-point perspective. Here you see the 2-point perspective when the two principal axes intersect view plane. Two principal axes intersect the view plane, then we said it is the 2-point perspective. Here you see the 3-point perspectives, where here you the two-sided, left side, right side, and the top elevation is also here. So which is known as the 3-point perspectives. So here you see, this is one point where you can see only the one side. It is the two side where you can see this also and this also. 2-point. In the 3-point where the object is 3D, means you can see the 3 dimensions of the object, and it is the example of 1-point, it is the example of 2-point, and it is the example of 3-point perspectives. So we are again defining, so perspective is rays conversion on eye position, but in the parallel rays are parallel. In the orthographic, rays are perpendicular to the view plane, but in the oblique, rays at angle to the view plane. In the elevations, view plane aligned with principal axis, and in the axonometric, view plane not aligned with the principal axis. When the view plane is aligned with the principal axis, then we set the elevation. When it is not aligned, then we said it is the axonometric. So this is the front elevation, this is how elevation works, this is the top view, side view and the front view. This is the front view, this is the top view and this is the side view. Next comes the isometric view. In the isometric view, the three principal axes of the object intersect the view plane at equal distance. Therefore, when the projected, they are 120 degree apart. So, in these three principal axes, x-axis, y-axis and the z-axis intersect. They all three intersect or meeting at some point with equal distance, and then we said they are at 120 degree apart. Then the projection is known as the isometric view. So, this is the 3D projections. How? In the oblique projections, projection lines are at one angle to the view plane, and let the angle be an angle of projection line makes with the view plane. Tan A is equal to 1 and A is equal to 45 degree, called the Cavalier projection, and A is equal to 2 or A is equal to 63.4 degree, called the cabinet projection. Then comes the orthographic parallel projection matrix. When transform each vertex from viewing coordinate into normalized coordinate using orthographic projections. Suppose that a point is xyz in viewing coordinates. What is the transformation necessary to transform it to x-axis, y-axis and the z-axis dash in the normalized coordinates? Given the dimension of the view window, that is xw mean, xw max, yw mean and the yw max. So, this forms this metric. So, the suppose camera position is at origin 0, 0, 0, that is your x is 0, y is 0, z is 0 and the view plane is at a distance t from origin. Then this consider the top view. So, this projection will be achieved or formed by this here x axis, this is the 3 dimensions are at 0, 0, 0. So, original this is the x object and this is the how elevation or perspective projection works. This is how the matrix will work. So, in the last we will discuss all of the definitions again in detail. So, first is projection. The process of displaying 3D into a 2D display unit is called projection. So, when we have to convert the 3-dimensional object into the 2-dimensional display unit, we called it projection. And the projection transforms 3D objects to the 2D projection plane. But the parallel projection is one in which z coordinate is discarded and parallel lines from each vertex on the object are extended until they intersect the view plane. So, they do not intersect at any point, that is why we call it the parallel projection. So, the projection is the process of displaying 3D into the 2D display unit is called projection, and the projection transforms 3D objects to the 2D projection plane. But in the parallel projection is one in which z coordinates is discarded and parallel lines from each vertex on an object are extended until they intersect the view plane. Then comes the perspective projection. In the perspective projections is the one in which the lines of projection are not parallel. Instead, they all converge at a single point called the center of projection. So, perspective projection is one in which the lines of projection are not parallel. Instead, they all converge at a single point called the center of projection. Then comes the projection reference point. In the perspective projections, the line of projection are not parallel. Instead, they all converge at a single point called projection reference point. So, the projected reference point is in the perspective projection, the lines of projections are not parallel. Instead, they all converge at a single point called projection reference point. Then comes the parallel projection. The parallel projections are basically categorized into two types depending upon the relation between the direction of projection and the normal to the view plane. They are orthographic parallel projection and oblique projection. So, the parallel projection are basically categorized into two types depending upon the relation between the direction of projection and the normal to the view plane. They are orthographic parallel projection and oblique projections. Then comes the orthographic parallel projection. When the direction of a projection is normal, that is perpendicular to the view plane, then the projection is known as orthographic parallel projection. So, when the direction of a projection is normal or perpendicular to the view plane, then the projection is known as orthographic parallel projection. And in the orthographic oblique projection, when the direction of a projection is not normal or perpendicular to the view plane, then the projection is known as orthographic parallel projection. So, orthographic parallel projection is of two types. The one is orthographic oblique projection and the other is axonometric orthographic projection. The axonometric orthographic projection is the orthographic projection can display more than one face of the object. Such an orthographic projection is known as axonometric orthographic projection. The orthographic projection can display more than one face of the object, such as orthographic projection is known as axonometric orthographic projection. Then comes the Cavalier projection. The Cavalier projection is one of the type of oblique projection in which direction of a projection makes a 45-degree angle with the view plane. That is known as the Cavalier projection. The Cavalier projection is one of the type of a oblique projection in which the direction of a projection make a 45-degree angle with the view plane. Then comes the cabinet projection. The cabinet projection is one of the type of a oblique projection in which direction of a projection make an arc tan 2, that is 63.4 with the view plane. The cabinet projection is one of the type of oblique projection in which the direction of a projection make a arc tan 2 is equal to 63.4 with the view plane. Then comes the vanishing point. This is the one of the anomaly of the perspective projection in which the perspective projection of any set of parallel lines that are not parallel to the projection plane converge to the point them is known as the vanishing point. So, the perspective projection of any set of parallel lines that are not parallel to the projection plane converge to point them is known as the vanishing point. Then comes the perspective foreshortening. It is also one of the anomaly of this perspective projection in which the farther an object is from the center of projection, that is COP, the smaller it appears. that is the projected size become smaller. The perspective foreshortening is farther of an object is far center of the projection, the smaller it appears. Its projected size become smaller. This is all about this lecture. Thank you very much.